So basically in organic chemistry, basic basics of organic chemistry, like including the definition of organic chemistry, that is the study of hydrocarbons. Like those compounds which contains carbon and hydrogen are known as hydrocarbons. So basically is the study of hydrocarbons. But if you can see alcohol, if you can see carboxylic acid, and if you can see an ester like amine, then amide, like a lot of functional groups we have. In those functional groups, along with the carbon and hydrogen, you will see other elements as well. Like you will see oxygen, you will see nitrogen. Okay. So those compounds are also lie in the category of organic. Basically, they are the same thing, like they are not pure hydrocarbons, but they are the derivatives of hydrocarbons. So the definition of organic chemistry would remain the same. It won't change. The definition would remain the same, like the study of, I can say, hydrocarbons. Okay, so we will be starting from the naming and also from the representation of organic compounds. Like a lot of organic compounds have been discovered so far, like more than 10 millions of organic compounds have been discovered. So of course, if you can see the periodic table, we have total around 120 elements. So up to these 120 elements, we have arranged in a multiple manner. Like we made groups, we made periods, and then we have classified them into different their own groups, like alkali metals, then alkaline earth metals, then transition elements, then the noble gases we have, and then we have halogens like group 7 elements. So we have categorized in a proper way, and it took a lot of time. Multiple scientists were arranged different things, like someone have introduced the concept of column, like the table in which we have different columns and different uh, periods and groups, I can say, rows and columns. So for 120 elements, we have arranged in this manner. So what if we have more than 10 millions of organic compounds? Then what we are supposed to do for that? This is one of the reason that we have to classify organic chemistry, like organic compounds, into different categories. Like this is known as functional group. So we have multiple functional groups, like we have alkane, then alkene, then alcohols, then carboxylic acid, then ester, amines, amide, halogenoalkane, aldehyde, ketone. So we have different functional groups. So what we say, like it's just like lithium is in group 1, so means it would be more reactive, because we know group 1 elements are more reactive. In the same way, group 2 elements are also reactive, but the reactivity of group 2 element is lower than the group 1. So in the same way, if we can see OH in any of the compound, let's suppose if I have this one and this one, let's say, so this is going to be alkane, like this is methane. But if I can see this compound, so I would say that this is going to be alcohol. So if I can see OH group with any of the molecule or a compound, so I would say that this is going to be an alcohol. This is the identity of the particular functional group. So we have a lot of functional groups. The thing is that like uh, in similar to the periodic table, so we have also classified organic compounds into different categories on the basis of their family members, on the basis of the functional group. So let's say if I have C and then C double bond O and then OH, and then this is going to be CH3. So this is called carboxylic acid. In fact, this is known as ethanoic acid, carboxylic acid. So the identity of carboxylic acid is that the presence of this group. In the same way, if I can see double bond, if I can see double bond between the carbon-carbon atom, so I would say this is going to be an alkene. And if I can see CH3NH2, this is going to be amine. So this is the short intro of different organic compounds in different categories. So, and then the question is, how can we represent organic compound? Like the how many ways of representations we have. I mean to say, let's suppose, what's the formula for H water? You will say H2O. I can also represent this H2O like that. This is the way of representation in which I am going to show each and every bond, like how the oxygen is connected with hydrogen, and same goes with a lot of molecules we have as an example. You know, this is known as displayed formula.
By the way, when I'm doing this discrete formula, do I need to take account of the angles and whatnot, like the lone pair repulsion and all that?
What are you saying?
Like, do I need to show the H2O like as it's like with the angles and whatnot?
Not the angles right now, because this is the general representation. Let's suppose
No, no,
we
like
have.
how we did the lone pair stuff. So we
No, no, no,
didn't
no.
show
It's not
H2O.
like we are not discussing the geometry of the molecule. No, it's
Okay,
something else. Okay.
right.
So we have different ways of representation. Number one, uh, representation of organic compounds. Representation of organic compounds. So number one is molecular formula. Molecular formula. And then we have empirical formula. Empirical formula. And then we have displayed formula. Displayed formula. Then we have structural formula. Structural formula. And then we have skeletal formula.
Okay.
Skeletal formula. These are the different ways of representations. Let's say uh, I have methanol, let's say, sorry, ethanol. Ethanol. So number one, we need to know the molecular formula for methanol. Molecular formula.
All right.
So the molecular formula for ethanol is C2H6O. This is the molecular formula of ethanol. And then if I know the molecular formula, so what would be the empirical formula? Empirical formula is the simplest form of molecular formula. So what I need to do, if
Hmm.
the formula is cancelled by any number, so we can write down the empirical formula, otherwise not. Like if you have C6H12O6, it can be divided by 6. It can be simplified. I would be getting CH2O. So empirical formula is CH2O, and this is going to be the molecular formula. So in the same way, if I can cancel this one, so I can get an empirical formula, otherwise no. So carbon and hydrogen can be cancelled by 2, but what about oxygen? So no, empirical formula is not possible. It would remain the same, C2860. It cannot be simplified further. It is already in the simplified version. So this is going to be the empirical formula. And then what would be the displayed formula? Displayed formula is the one in which each and every bond must be shown. Even carbon-carbon bond, carbon-hydrogen bond, oxygen and hydrogen bond, CH3COOH like carboxylic acid bond, NH bond, like each and every bond must be shown. So this is going to be displayed formula. So let's suppose I have two carbon atoms like that. Carbon is connected with carbon, keeping in mind the valencies. Since the valency for carbon is 4, so it's going to make 4 covalent bonds, and the valency of hydrogen is 1, it can only make 1 bond, and the valency of oxygen is 2, it can only make 2 covalent bonds, and the valency of nitrogen is 3, so it can make 3 bonds, depends on the group number. So this is the displayed formula for ethanol, like that, in this way. This is the displayed formula. Even if you will be writing OH, so you won't be getting the mark because you have to mention the bond of oxygen and hydrogen. Each and every bond you have to show. You have to clarify it. And then
Okay.
we have a structural formula. A structural formula. Structural formula we can see after looking at the displayed formula. It's going to be CH3. It's going to be CH3. And then we have CH2. And then we have OH. This is the structural formula. And then skeletal formula. In skeletal formula, we are not supposed to show carbon and hydrogen. We are not supposed to show carbon and hydrogen. So the corners are going to represent the number of carbon atoms. And if you wrote the number of carbons, like I mean to say the corners, so this is understood that with each and every carbon, there are hydrogen atoms because we have to fulfill the valency as well. Like I have two carbons. So I mean to write like that. This corner, like these two corners are going to show that we have the two carbon atoms. We have the two carbon atoms. The carbon which is connected to another hydrogen, so we are not supposed to show that hydrogen. Like I mean to say, you must not write like that. This is already understood because the valency of carbon is 4. If you have drawn only one bond like that between the carbon-carbon atom, so
Hmm.
understood that there are hydrogen atoms. But we cannot show in the skeletal formula. This is the simplest way to represent an organic compound.
Wait,
Then
wait.
what
So
about
this skeletal formula that you have just shown, what does this represent?
like these corners are representing carbon atoms?
And the middle?
No, corner, only corner, like that.
Oh,
If I have to draw three carbon atoms, I would be drawing like that. Three corners. If I
okay.
have to draw four carbon atoms, so I have to draw like that. One, two, three, four.
And then so on and so forth.
Yeah,
Okay.
exactly. So in our syllabus, according to the Oxford AQA specification, we have to show up to 6 carbon atoms. This is the syllabus. So we are so limited. We are not supposed to write more than 6 carbon atoms. Even when we will be doing IUPAC naming, so we have to be in the limitation of up to 6 carbon atoms. So then OH is remaining. How can I show oxygen and hydrogen bond in skeletal formula? So I can do like that, or even we can do like that. This is going to be skeletal formula for ethanol. Okay. Since we know that the valency of oxygen is 2, since we know that the valency of oxygen is 2, so this is understood that when oxygen has made a one bond with the carbon atom, so another bond of oxygen will be with the hydrogen atom. Okay. So this is for the ethanol. So we have multiple functional groups that we have to do, including alcohols, including alkane, including alkene. Okay, so we have to do that as well. And then we have, I can say, what if I have butane? What if I have butane? So I'm going to copy this all. We have to do this all or like that. Since the molecular formula for butane is C4H10, because this is an alkane, and the general formula for an alkane is CnH2n plus 2. So in this way, I can say, in this way, I can say uh, the molecular formula for butane is going to be C4H10. So what do you think? What should be the empirical formula of C4H10? What do you think? Of course, we have to,
Four
of course, we
H10.
have to simplify it.
Yeah,
Of course, we
C4H10.
have to simplify it.
Yep, simplified. So that would be C2H5.
So it's going to be C2H5, isn't it?
Yeah, yeah.
And then we have to write the displayed formula. So it's going to be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2, 1, 2, 3, 4. So this is the displayed formula for butane. And structural formula would be CH3, then CH2, then CH2, then CH3. With the first carbon atom, I have 3 hydrogen atoms, so I'm supposed to write CH3. You can also write H3C, the same thing. With the second carbon atom, I have 2 hydrogen atoms, so I would be writing CH2. With the third, I have again 2 hydrogen atoms, so I would be mentioning CH2, and then again I have CH3. This is going to be the structural formula. And then what about the skeletal formula we have? So we have 4 carbon atoms, so I have to show 4 corners, 1, 2, 3, 4, and that's it. This is the skeletal formula for butane. And in the same way, uh, let's say I have pro propane to all. Let's say I have propane to all. So so propane to all is also propanol. We will be discussing the concept of isomerism, that like what is the difference between propane one all and propane two all, and that all of the stuff. The thing is, what would be the molecular formula first for propanol? So we need to know the general formula for alcohol, that is going to be CnH2n plus 1 OH. This is the general formula for alcohol, right? So if I can look at this formula, so the formula for propanol is going to be C3H8O. This is going to be the molecular formula for propanol. When we generally write down the molecular formula, so the position of the functional group is not mandatory to show, because this is the general formula in which the position is not considered. And then we are going to show empirical formula, so it cannot be simplified further. It would remain the same, C3H8O. Now we have displayed formula. So in the displayed formula, what I am going to do, it's propane 2-ol. I have to attach OH on the second carbon atom like that. Rest of the elements would be the same like that. This is propane 2-ol. Then I have structural formula, CHOH, then CH3. By the way, this OH is the branch. Like OH is attached to the second carbon atom. So we have this condition, so we have to show that group in bracket. We have to show that group in bracket. So we have to do multiple things, including all the compounds which have different branches. So the branches have to be mentioned in group. And then how can I draw the skeletal formula? So we have 3 carbon atoms with this oxygen. So this is going to be the skeletal formula. Okay. And
Okay.
or I can say, and this is going to be, by the way, OH. The hydrogen which is connected to oxygen, it must be shown, right? The hydrogen which is connected to carbon, they are not supposed to show. The
Okay.
hydrogen which is connected to carbon, okay? Or what
Wait, so you
if
write O and H or do you write only H?
OH,
Right, right, okay. Like that. Right.
okay? Because this hydrogen is with the oxygen. So what we have assumed, those hydrogen which are with the carbon, they are not supposed to show in the skeletal formula. Or then we have, for the practice, I would show how I'm going to write down this name. 2,2-dimethyl propane. 2,2-dimethyl propane, let's say. So let me tell you the formula first, the molecular formula. How many carbon atoms we have? So we have in total 5 carbon atoms. How? This is prop, means 3. This is di, means 2. So the total carbon atoms I have is 5. Since this is an alkane, so the molecular formula is going to be C5H12. This is the molecular formula. Empirical formula is going to be the same. It cannot be simplified further by any number or okay. So the displayed formula means 2, 3. At the second position, we have 2-methyl. This is going to be the displayed formula of the given name.
What if it is
We
like called okay, I have one question. What if it is called
Yes.
My question here is that the 2 comma 2, right? They're like two twos, yeah. Like
Mhm.
1 2 is for what, and what's the other two for?
Basically, at the second position, we have two methyl groups. So the first two is for this methyl, and the second two is for this methyl.
Right.
This is the
Okay.
proper way to name the compound because
What
sometime
if
it
it
would
was 2 3? What if it was 2 3?
in the propane, the third position is not possible. The second position
Oh
is
yeah, yeah,
possible.
I
Yeah,
remember. I remember.
exactly. Yes.
I remember. But in
So
like
this is
butanol, it there is also the third one, which is the middle one. No, no. In also butanol, is there a third position? I think you count
yes.
from the right or left. It's your choice.
Basically, when you are going to write butanol, so if this is
Yeah,
going to be 2 all, so this is going to be 3 all. Like
right.
one,
Or you
two,
can do the
three,
opposite as well, right?
1, 2, 3, 4, the same thing.
Yeah, same thing,
In
right?
both
Got it.
conditions, they are getting the same numbers, 2 and 3.
Okay, got it.
So a structural formula. Then what do we do in a structural formula of this 2,2-dimethyl propane? I'm going to write CH3, then I have C. At C, I have two CH3s. Then again CH3 I have. Then again CH3 I have. Then what about the skeletal formula? So I can draw like that. This is going to be skeletal formula, or even I can draw like that. In the both structures, there are 5 corners. So means 5 carbon atoms.
Do you not have to
Simple.
mention? Oh, right, right. Okay, okay. Makes sense. Got it.
Yes.
Okay. All right.
Okay. Okay. This is the way of representing some organic compounds. Let's say if I have propanoic acid, it's oic acid. So propanoic acid means this is going to be carboxylic acid or so propanoic acid is going to be CH3, CH2, C double OH. So the formula is going to be C3H6O2. So the empirical formula would be nothing, the same. Displayed formula I can write. No, 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 no. Oh, 3 carbon atoms I have. So C double bond O and then OH. Then structural formula is CH3, CH2, COOH. Skeletal formula, 3 carbon atoms. Skeletal, oh, skeletal formula, 3 carbon atoms with this one, or I can also write like that, the same thing. It's up to you. Or okay, so this is propanoic acid, and Basically, in in specification, we have till, I can say, alcohols. We have till alcohols. So we are not supposed to do a lot of things. It's already limited, but we should know if there is any of the compound or a molecule. So how can we represent this in multiple ways? So according to that, we have different ways. Number one is molecular, then we have empirical, then and also you need to know the general formula as well. But I would be mentioning the general formula when we would be starting particular functional group. Like let's say, as I told you that the general formula for alkane is going to be CnH2n plus 2. And in the same way for alkene, the general formula is going to be uh, CnH2n. Then in the same way, the general formula for alcohol is going to be CnH2n plus 1 OH. What if I have bute, bute 1 comma 3 diene, bute 1 comma 3 diene. So bute 1 comma 3 diene, first of all, you need to know the molecular formula, right? But the normal general formula would not work for that. Because if we have one double bond, so we can apply the general formula that is going to be CnH2n. But in this compound, there are two double bonds, right? So we have to draw first like that, C like bute, and then one, and then one, two, three, then this one. So if I have to complete the double, like the bonds, I have to fulfill the valency of carbon. So it can be shown like that. So the molecular formula is supposed to be C4H6, can be simplified into C2H. Yep, C2H3, or displayed formula I did like that, or I can say structural formula is CH2, then CH, then CH. Yeah, then CH, then CH2. Yep. Skeletal formula, we have four carbon atoms. This is going to be the double bond. This is going to be the double bond. Whenever we have, whenever we have an alkene, right? So, uh, okay. Then afterwards, as I told you that we have to arrange or classify organic compounds into different categories on the basis of functional group. And also we will be using the term homologous series. We will be using the term homologous series. What the homologous series is, what the homologous series is basically, this series will be consisting of alkane, will be consisting of alkene, alcohol, or carboxylic acid, or all like that. Okay, so we have to consider all of the functional groups that we have. Okay, let me show you first of all. Number one is that mm, let's say homologous series. Homologous series. Homologous series means the series in which the difference of two consecutive group is CH2. The series in which the difference of Two consecutive compound is CH2, right? Let's suppose for alkane, for alkene, for alcohol, for haloalkane. Haloalkane means when halogen is attached with any of the carbon containing group, right? So how can I explain homologous series in all of the functional groups, right? So let's say starting
Sir,
from
by the way, you wrote ALC, I think. Is that a typing error or is that something else?
this one, alkane, this one.
Yeah, yeah, right, right,
Yeah,
right,
this is an alkane, right?
right, right.
Or so methane, ethane, propane, butane, pentane, hexane. In the same way, I would be doing starting from alkene. For alkene, the first family member is not possible, like methane, because carbon cannot make double bond with hydrogen. It's not possible. I would be starting from ethene, C2H4, C3H6, C4H8, C6H12, CH3OH, C2H5OH, ethanol, C3H7OH, propanol, C4H9OH, it's butanol, C5H11OH, it's going to be pentanol, and then hexanol. For haloalkane, halogen, it may be any of the halogen. I'm assuming that this is chlorine. CH3X. Let's suppose this X means halogen. C2H5X, C3H7X, C4, sorry, 13X. This is halo group, halo compound. So what the homologous series is, the difference between the two compound, whether you have alkane, whether you have alkene, whether you have alcohol, it's going to be whether you have haloalkane. The difference is going to be the same. That's CH2. One carbon and two hydrogen atom. The difference would remain the same for all. So this is homologous series, this is homologous series, this is homologous series, this is homologous series. This is also the way of rearranging organic compounds, or I can say classifying organic compounds on the basis of homologous series. So What should be the characteristics of homologous series? I can say, like, I'm just limited to this series. This is going to be an alkane. Then same goes for this, and this. All the series have different chemical properties. Why? Suppose um, alkane has different chemical properties. Alkene has different chemical properties. Generally, alkenes are more reactive and alkanes are less reactive. Alcohols have different chemical properties. Haloalkanes have different chemical properties. But the thing is that if I discuss within the same family members, like the comparison of methane with ethane, with propane, with butane, with so on. If we do comparison, so the chemical property would be the same because they belong to the same family. Because they belong to the same family. So that's why the chemical property would be the same, but the IMF is different. You know, when the IMF, why the IMF is different? Like I'm talking about the London force, van der Waals force, dispersion force, ID force, because they all are nonpolar. And in a nonpolar, we have ID force. Different molecules have different van der Waals force. So means that the physical property would be depending on the IMF. So IMF would be different. Like the physical property is different. This is also the characteristic of a homologous series. And I can say they have the same general formula. Like this is an alkane, 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 alkane. The general formula would remain the same, CnH2n. If you talk about this one, the same thing, same general formula, or same chemical property, because alkene, all are the family members of alkene. So they would be having the same chemical properties, but they would be having different physical property due to different IMF, right? Or if you talk about alcohols, so alcohols, we have different family members starting from methanol, then propanol, then butanol, and so on. And if you talk about haloalkanes, again, I can say uh, within this family members, the physical property would be different, but the chemical property would be the same. So the first characteristic is going to be the same chemical properties.
Okay.
Same general formula.